Hello all, welcome to our project Concrete Compressive Strength Prediction. So now in this project what we'll be doing, we'll be predicting the correct concrete compressive strength using different machine learning and auto machine learning techniques. So now basically you must have seen heard that this is a basically a core project, right? This is a very off topic project. Who does a concrete project, right? But in the field of civil engineering or in the field of civil engineering or the core branches, the machine learn in where machine learning is applicable, we can use this project. In this project, the main motivation is that we all know that concrete is the most important material in civil engineering, right? So the concrete compressive strength is a highly non-linear function of agent ingredients, which means that it depends variably, it depends on various factors. So there are several ingredients in concrete, which are cement, blast furnace, slag, fly ash, water, super plasticizer, and coarse aggregate and fine aggregate. These are the basic materials which are used in a concrete. So now moving on, what we'll be doing, so we'll be trying to predict the different concrete strengths of the cement with the help of the information which I told you earlier given to us. So now how we'll be doing it, so we'll be using the help of deep learning methods. We'll be using Keras sequential model to predict the strength. Then we'll see how you can implement the same thing using the auto Keras library, which is a auto machine learning library. So now moving on, what is auto machine learning? Auto machine learning enables developers with limited machine learning expertise to train high quality models specific to their business needs. Basically, automated machine learning automizes the whole model development process and give it to the user. There are various automated machine learning libraries, but in this we'll be using the AutoKeras. So now what AutoKeras is, you must have heard about the Keras library. We'll be using it in the project. So AutoKeras also is an AutoML system which is based on Keras. It is developed by the Data Lab at Texas A&M University. The goal of AutoKeras is to make machine learning accessible to everyone. Okay. So there are certain applications for AutoKeras, which are the regressor or the image classifier, object detection, all the things which we do with the Keras library, with the deep learning library, we can do the same with the help of AutoKeras. Now what will be the timeline of the project? In this project we'll be first doing the data analysis, visualizing our data, then we'll be doing the data pre-processing techniques, different techniques to make our data ready for a model, different feature engineering techniques. Then we'll be building our model with the help of deep learning or machine learning techniques. Then we'll be using the AutoKeras to see how we can do the same. So let's begin. Hello all, welcome to our project Concrete Compressive Strength Prediction using deep learning and automated machine learning, that is the AutoKeras. So now in the introduction section I have already told you why this project is important, what is the motivation behind this. The same is written here that the concrete is the most important material in civil engineering and it cost varies in a long non-linear function. So what we'll be doing, we'll be predicting or we'll be making a model to predict the compressive strength of this cement. So now there is some data characteristic. The actual concrete compressive strength is given in MPa for a given mixture under a specific age was determined from laboratory. This is the data which we have given. Okay. So now we'll be seeing what is our data, but the very first thing is the timeline of the project. So now what we'll be doing, first we'll be doing the data analysis, then we'll be doing the data pre-processing, feature engineering, then we'll try to build our model using the deep learning techniques, and we'll be trying to build a model using the different automated machine learning technique, that is the AutoKeras. So now let's proceed. So very first thing what we'll be doing, we'll be importing our libraries. So I've imported pandas, NumPy, matplotlib. These are for various visualization and data processing and pre-processing techniques. So now what you have to do is, in order to import this library, in order to import data in your Google Colab environment, first you have to import your CSV file in your Google Drive environment. Okay, then what you have to do, you have to mount your drive. You have to mount your drive. When you will click on this, when you click on this link, this link mount drive option, it will give you this option. Then you just have to click on this link. Then you have to just authorize your account to give permission so that the Google Notebook can Google can access your data. You just have to copy this authorization link here and paste it here, press enter. What this will do, it will automatically mount your drive. Then what happens is, once your drive is mounted, as it is written mounted at content drive. So now when your drive is mounted, it is shown here and all the files are here. Then I'll just copy my file path, that is the cement.csv or something of that concrete data.csv. I'll just copy the path from finding it here, and I'll just copy the path like this, and I'll paste it here, and I'll just read it using the pandas. So this was a simple way how you can read your file. If you want to see the shape of your file, of your data, so there are 1030 rows and 9 columns. As you can see, this is the different attributes given, which I mentioned in the introduction part also. Okay, how the cement is constructed, that is the cement, blast furnace, slag, fly ash, water, super plasticizer, coarse aggregate, fine aggregate, age, and this is our dependent variable, that is the concrete compressive strength. So now we'll be doing some data analysis part and the feature engineering, data pre-processing techniques, model building using auto Keras or and Keras module in the next sections. Hello all, welcome to our next section of this project. So now in this section, moving on further from the introduction part and import part, we'll be doing the data analysis of our data. So now previously what we did is we did the introduction of our data, then we saw that how we can import our data in the Google Colab environment. So now in this section we'll be doing the data analysis, describing our data, visualizing our data, and all of those different things. So first let us have a look at our data. This is our data. I have already told you what are the different variables and how they are responsible for the concrete compressive strength prediction. So now, and this is the shape, that means that we have 1030 rows, that means 1030 cement data and 9 columns. These are in which 8 are independent columns and the ninth one is concrete compressive strength, that is a dependent column. So now what we'll be doing, let us describe our data. So as we see that all our data are in numerical format, so it is very easy for us to describe our data in the form of certain mathematical abbreviations. For example, we can see that what is the count, we can see mean of each and every column, and we can see standard deviation, we can see what is the maximum value and minimum value, then all the percentile region. So this is a brief outlook numerical out analysis of a data. Now the same thing I can do, that I can see the info, which means in which I'll be seeing that okay, what is the basically what is my data type and how, what is my data type of my columns. So as you can see, all are float and integers only. Float are these and only one is integer, that is might be the age. Okay, the one is the age is the integer. Then we'll see that if our data contains any null values or not. So hopefully your data is not having any of the null values. So if it would have been having the null values, then we would have to deal with the null values, which in the by the different methods, which include like we can replace the null values with the mean, median, mode values, or we can replace it with a recent sample application, sample variable, or any of that sort, right? But there are no null values present. So now the next thing I'll be doing is I'll be plotting a heat map, right? So now in that for that I'll be using the C1 library. So earlier I have imported the matplotlib library, which is also for visualization. Now C1 library is basically a library which is also for visualization direct of complex variables or complex visualization techniques. That means the for example the heat map. Okay, there are different heat map present. In this we'll be plotting a figure. In this I'll be saying that okay, import cbon as SNS, then I'll be saying okay, plot a figure of the size. I have given the size of this, then I'm saying okay, plot and heat map, in which for the data, for the sake of data, what I'm doing, I'm providing a correlation matrix. Okay, now if I'll see that, if I'll directly write what is a correlation matrix. So when you will see in a numerical format, this is my correlation matrix. Basically it correlates, it gives the correlation between my each and every feature. Okay, each and every feature, if it is negative, that means it is negatively correlated, positive means positively correlated. Higher the value, higher is the correlation. So now what I have done, I just simply visualize this data with the help of heat map. Now I cannot understand, I have to look at each and every variable in this, but in this I can see that okay, which is highly correlated or not, with or negatively or positively, with the help of these color schemes also, that the negative to positive color scheme is given and everything is given. So I can easily say that okay, how my data is correlated, if they are positively correlated, negatively correlated, highly correlated, not highly correlated, all of these things. Okay, so now what we'll be doing, then I'll also be plotting a scatter plot. Now in this I am plotting a scatter plot for all my variables. The same what I did is similarly as I did for correlation, right? My correlation is predicted for each and every variable, for cement to blast furnace slag, fly ash to competitive slend, age to water. For in the same thing I plotted a scatter plot. What I did, I used a for loop. In that I said that okay, for I in df columns I defined a certain variable in df dot columns. Then I'll said okay, for j in df columns, then I chosen my x value, I have chosen my y value. These will be two different values. So now I am saying plot a figure, then I am saying plot a scatter plot between them. I am passing my x value as my I am passing my j value as my j. So now it will iterate for all how that many times, that for that many times in which my all the variables are covered, right? If my all the variables are covered, that means for that many time it will iterate and plot a scatter plot. For with the help of this, as you can see, my scatter plot is plotted for each and every variable. Now from this I can have an idea, okay, how my variables are distributed and how my variables are correlated, right? As you can see, if the plot is in a straight line, which is this is cement versus cement graph, so obviously it will be a straight line because all the variables are same. But in this, for the concrete compressive strength variables, see how my different strengths are related from the blast furnace slag, then fly ash. First, the cement scatter plot is plotted with for all these things, for all the different variables, for all the different variables. So I can see my scatter plot for all these, for cement versus water, cement versus super plasticizer, cement versus coarse aggregate. Similarly, okay, you can execute this command and have a look at your own and analyze, okay, how my data is distributed and how my data are there. As you can see, for cement, for different ages and cement, it is almost the same concrete compressive strength. For all the different display age, for cement and age, it is same for different age criteria, right? So similarly for the all the different things. Now first the cement was plotted, then for all the variables the x-axis will be blast furnace slag. Similarly the x variable will change for all the different attributes. So as you can see, there are many number of scatter plots which will be plotting. So this is basically a very good method of seeing things, or seeing okay how my data is distributed or how my data are correlated. As you can see, there are numerous amounts of scatter plot. You can have a look at it and you can see okay how are these distributed and all of these things. So now the next thing what we'll be doing is we'll be doing some outlier analysis. So every data is outlier, right? So we'll be seeing okay what is the outlier for this. For that, I've done, I've defined a function. In that I've defined it as an outlier. I'm passing my data and then I'm passing my column. I'm saying plot a figure, I've given a size, then I'm saying plot a box plot for it. It is a very simple function. I'm just iterating my for different columns, and I'm plotting my box plot for all of these. So as you can see, the black marks are my outliers. I am getting my outliers for all, but hopefully there are not much outliers in our data. Many of our outlier free and only some of are having 2 to 3 outliers. So now we can replace the outliers. Then how we'll be doing that? We can replace that outliers by replacing it with the maximum and minimum value. Okay, we can replace or remove these outliers. Basically what I'll be doing, I'll be removing these outliers. How I will see that? First let us see that what are the maximum and minimum values for it. So for that I've defined a function end value show. So now what this will do, I have printed minimum value of dash is dash min max value. So now what I am taking columns, the it will be printing minimum value of that column, and then I am saying okay, data dot column dot minimum and data dot column dot maximum. It will just provide me the minimum and maximum value for that is the this bar value. So I am just iterating the function for all my columns. Now as you can see, this is my column. Minimum value is this, maximum value of this for every other attribute. So now I can replace the this is basically the maximum value, this is the outlier, right? From this, and I can have a look okay how my outlier is. For outlier is how far is my outlier with my 100 percentile of the data. So now this is my 100 percentile. That means for concrete compressive strength the maximum value is 82.6 and my 100 percentile data is 80%. That means my outlier is not too much far. So I can there is no need to replace the outlier because this is very close to my endpoint value. So now what I'll be doing, I'll be removing the outliers which are very far away from the endpoint values. That means for the age value, blast furnace, lag, and super plasticity, I am taking only those data set in which they are having the I am taking the data set between the 0th percentile to the 100th percentile only. For example, if for the blast furnace slag I am taking the data less than 350. So if you will see in the blast furnace slag the data outlier is far away from 350, but my 100 percentile value is this. So I've taken the data from this only. So this very few data will be removed, and this will create no other effect in our data, and our data will be more cleaner. So now I replaced my outliers. So this was all about my data visualization and feature engine, basic data pre-processing techniques. So now in the next section we'll be doing a little bit of feature engineering, because this is a very small data set, there's not much to do. So we'll be doing a little bit of feature engineering, then we'll be splitting our data and making our data ready for our model building techniques. Hello all, welcome to the next section of our project. Now after the data analysis and all of these things, data pre-processing thing, the last thing left before our model development phase is the feature engineering. So now what feature engineering, in this we are in the feature engineering we create or drop different features in order to, basically this is done by a domain knowledgeable person who knows that okay, what features can be my important. We can create new features, we can see okay, what are the different features which can help in our better prediction. We can create different features with our domain knowledge. So that is basically a feature engineering. So now in this there is a very small data set and we don't know much about this. Obviously this is a civil engineering project, so we'll be doing the basic feature engineering based on our data analysis we did earlier. So now first let us have a look at our data. So now this is our data, and this is our columns. So now previously in the by plotting the heat map and the data and the scatter plot which I plotted, I found out that the blast furnace slag, coarse aggregate and fine aggregate are not much correlated with my concrete compressive strength. Okay, when you'll see the heat map, if you'll see the heat map, then you'll say, also if you want to see the scatter plot also. So now in the blast furnace and concrete as you can see 0.13. Okay, this is a very less correlation, and similarly the fly ash minus 0.11. So this is not much correlated with my concrete compressive strength. So what I can do, I can basically drop these. So it will my model will have less data, but it will perform well. Okay, it will split, or it will make the data well, it will fit my data well. So that is why I am dropping these columns. I am just basically using the drop command, and in place is equals to true. Then if I'll see my df dot columns, so these are my final columns which are left. And if I want to plot a heat map between them, so this is basically the heat map. So now in this, when you will see that okay, now in this variable all of my variables are highly, at least some of them are correlated in a better way with the concrete compressive strength. For example, if we'll take age, it is 0.52 correlated, super plasticity is 0.41, water is minus 0.38, fly ash is this, and cement is 0.48. That means that this is basically we can see okay, these are correlated, and this will give some effect to our compressive strength. So that's why we removed those previous columns, because they were of no use, they were not showing any of our relatability with our dependent variable. So now this is our feature engineering also done. As I said, this is a very small data set, so this is not much to do. If there is some domain knowledgeable person, or he knows that okay, if I can multiply, divide or add new columns, so it will be of more help. You can do it if you have a person from civil engineering background. If you are a person from civil engineering background, you must have known okay, what are the different other categories which I can form with this, which will help in predicting my compressive strength. So you can take it as an assignment when you do it on your own, but this is for now for this project in the feature engineering part. So now in the next section what we'll be doing, we'll be splitting our data. So the splitting our data is very simple. I'll just be taking x and y. In that the x are my independent variables, sorry, and these are my dependent variables. This is my dependent variables. What I have did is in the x command I have said okay df dot drop the concrete cement strength, and in the y I have taken only that concrete compressive strength option. So now the last thing what I have to do is to split my data. So in this I am using a train test split function. This is the most common method which you can use for the splitting our data. You can import it from train model selection. What I am doing, I am just passing my function. I am passing my x data this and y test this, and I have written text size is equals to 0.3, which means that it will be splitting our data with a 70-30 ratio. 70% for the train data, 30% for the test data. Random state, you can select any of the random state. So now my data is splitted. Okay, now if you want to see what is my shape of data, so this is my x train shape. Now if you want to see what is my test shape, yeah, so this is my 286. The 286 rows were selected as my test, that is the 70% of the 1030 total data, and 5 columns. So now this is basically our data is ready. The one more thing also you can do is you can standardize this data also, right? Because this is this you can standardize this data also. I have not done in this project, but you can take it as an extra assignment. You can use standard scaler, which will scale down your values to a very small common platform, or min max scaler, which you can scale down your values from 0 to 1. So this is a pretty good thing to feed in your model. You can also do that. I have not done it here because in the last ultimately we have to demonstrate how you can do this with the help of AutoKeras, so it will handle all those operations. So now in the next section we'll be seeing how we'll be using the deep learning library, that is the Keras sequential model, for this project. Hello all, welcome to our next section of this project. So now previously in the previous sections we have done the data analysis part, feature engineering part, data pre-processing part. So now we have processed our data, we have made our data ready to feed our model. So now this is our model building section. In this we'll be using deep learning techniques, that is the Keras sequential model for this project, and we'll be building our model. So now what is Keras sequential model? So now if you'll just Google it for it, Keras sequential model. So this is the Keras sequential model. Okay, if you will see that from the definition, Keras document, the sequential model is a linear stack of layers. You can create a sequential model by passing a list of layers instances to the constructor. So now what basically it says that sequential model is basically a model which has different layers. Okay, in the different layers data is passed and processed, and there is a final layer, output layer, in which my data is given. So this is basically a basic architecture of a Keras sequential model. This is a basically a deep learning technique. So now what I'll be doing, I'll just be importing from TensorFlow, because Keras is present in TensorFlow. Okay, from TensorFlow.keras import models and layers, which means layers is important for importing, because the layers, with the help of layers only I'll be adding different layers. So now if I am executing it, and if I am executing it, so if it is giving you an error, if it is giving you an error for TensorFlow, it means that your TensorFlow is not installed in your system. You can basically go to a TensorFlow documentation and see how you can install TensorFlow. You can just install it, then execute this command, it will create no error. Now in the next, what I have done, I have defined my model. I have said okay, models dot sequential, that is a sequential model. I am saying okay, add layers. The first layer is this, then the second layer I have added is in for the activation function relu. Okay, there are different activation functions present. You can read what activation functions are. There are different loss functions also, so you can read okay what these activation functions are. And I've taken the shape from the xtrain.ilog.1.shape, basically the shape of the total data. And then I've dropped and I did another layer. For that I have activation function I've taken is tan h. Then I've saying okay, combine all these layers, model dot add layers dense, the model dot compile. Then I am saying optimizer function is rms prop, and loss is msc function, and matrix is ma. Basically my loss function is msc function, basically the loss function which will be created, which will be, that will be based on my msc function, and optimizer will be rms dot prop. So that it will be optimizing or updating my model with the help of this function. You can have a documentation of on a Keras sequential model in deep learning and see what all these parameters are and how these works in detail. Now in the next section, what did I just simply fit it model.fit. I've given my data X train, Y train. I've given how many epochs I have to perform. I've given batch size. I've given validation data as my test data. You can also create some partition for validation data also and test data for differently. But in this I have chosen on the similar on same variation for my validation and test data. So now in this is getting fit, it is performing 100 epochs. If you don't know what is epoch, epoch is basically a complete step of forward propagation and back propagation in a layer. That is then one epoch, and it is performing 100 epoch. Now when you see that after performing epoch, my main aim is to reduce my loss function. Okay, my loss function will get reduced, and the last epoch, my loss function started at around 1384. Okay, and my at the 100th epoch my lost function is around 323. So now it may be possible that my loss function might have reduced the lowest to an another epoch, like in the epoch number 387 my loss function reduced to 318, which is less than my last epoch, but it is okay. But the main aim is to reduce my loss function and to select the correct epoch. So now what I'll do, I'll just evaluate on my test data. Then it is saying that okay, my loss function is this, my MA is this. Okay, now my loss function is reduced more 276 with my X test and Y test. I'll just simply predict my prediction, and I'll okay see it. Okay, my what is my prediction? So I've taken only just one input. Okay, these are my different predictions. So now when if I'll go to then when if I'll go and see, okay, these are my different, it is a very long list. So I've just imported only one of that. So this is my different predictions. Okay, this we see that okay, how we can predict it with the help of deep learning, the normal deep learning tech. Now as this model has not performed that much well because our loss function is very big, it should be in the in at least in the decimal integers or close to the one range. Okay, so that is considered a very good loss function. But because this is not performed, because we have not done any much of the hyper tuning or any of the things, I have not done, because our main purpose is to show how we can do this using the auto keras. Then you said how drastically our outputs change when we using the auto keras, because it will be doing all of these things automatically. We don't have to perform any hyper tuning technique which you didn't perform in and obtained this much greater loss function is a very bad accuracy. Okay, so now in the next section we'll be seeing that how we can do all of these things with the help of automated machine library, that is the auto keras. Hello all, welcome to the final section of our project, that is the model building using the automated machine learning, the AutoKeras library. So now in the previous section we have seen the we have builder model using the Keras module. So now in this section we will be using AutoKeras. So AutoKeras is an AutoML system based on Keras. It is developed by Data Lab at Texas A&M and University. So now the very first thing you have to do, you have to install AutoKeras. Okay, you have to install AutoKeras. For that you have to write these commands. If you are using a local environment or Google Colab environment, you can simply write this in your notebook environment only with an exclamation mark, and you have to install all of these libraries. Okay, this will create basically a environment for the Google Colab, oh, sorry, Google environment for the TensorFlow AutoKeras. Then this will install AutoKeras. Then it will show what is my AutoKeras. So it will take some time, a minute or two, depending on your internet speed. As you can see, it is downloading a quite 454.5 MB file is there. So it is downloading the TensorFlow basically. So now in many of the things are already satisfied. It is written requirement already satisfied because I've already installed it on my system. You can install it in the command prompt from the command prompt also. But if you want to see the installation happening in your notebook for documentation purpose, you can directly install it on your notebook. But make sure to restart your notebook when you first install it, because whenever you install a library, the Google Colab environment or a Jupyter local Jupyter environment does not read it after it gets installed. Unless and until you will not restart your runtime, it will not read that library. So in order to read your library which is newly installed, you have to restart your runtime, then it will radio library. So now as you can see, it is basically saying requirement already satisfied. So it is basically uninstalling the libraries which is just installed because these were already present. So it will take a minute or two more. Then I have written a command which says that pip show auto keras, pip show auto keras. So now it is saying restart runtime, but I'll not do this because I have already installed it. Okay, I don't need to rerun it. So it is I have given a command pip show auto keras. It is showing me the details of the auto keras. What is the version, the summary, this is the home page of auto keras, that is the author email, the license, and all of these different things. This is the requirement packages, all of these things. Now we'll import auto keras. We'll first import. Okay, it is not importing, so I have to restart my runtime. I'll just restart my runtime for a one time. So now the very thing is, when you restart your runtime, you have to perform all of these steps again. Okay, if you want to read your data, you have to import all things, you have to perform all of these steps again. So now if I'll import my AutoKeras, it will not create any problem. As you see, this is imported. Okay, this was what I was saying, when you have to import, how you have to import your autokeras. So I'll just write define my model orchid structured data regressor. So as this is a regression problem, that is why I'm using structured data regressor. You can go to their website and see their documentation, what are the different commands you can use for regression. Basically for structured data, image data, there is a different command for defining our function, but all of these things. So now I'll be using the same data which I used for the previous sections, but as I restarted my runtime, I have to again load my model. And do all of these and do all of the data pre-processing techniques again. I'll just do all of these things again. It will take only a minute. This is basically the scatter plot. I don't want this. This is also a data which now in this I'll just replace the outliers and the feature engineering technique which we did. Then we'll just split our data, and perfect. So now this is our test data. So now we can simply pass this data into our AutoKeras model. I am just saying, okay, I am just defining my model as ak.structured regressor. Then I'll say overwrite is equals to true, and I'm saying max trials is equals to 3. Then I'll say reg dot fit. It what it will do, it will fit my data. It will fit. I am passing my data. I am passing my data as x train and y train. X data is my x train data which I've used, and y train is my y train data. So now it is basically fitting my model all over the. It is basically fitting my model. Then I'll see, okay, what are the different changes which are occurred when I did it using the Keras module without any hyperparameter tuning and simply passing my data. As you see that we had a very big loss function, but in this I am passing the same data, but when you will see that there is a huge difference in our accuracy and our results when you're using the AutoKeras. But because what AutoKeras is doing, it is basically checking all my models and all the different parameters which can happen for a AutoKeras for in a AutoKeras module, and giving me the best possible outcomes. So now it may take some time because obviously it is getting fitted, and it is a huge operation. It is a not much big data set, but again it will take some time, basically a minute or two to get fitted completely. By that time we'll see the different other things, the next step what we'll be doing. So now in the next step, what we'll be doing, I'll be evaluating a model. The same thing which I did earlier in the Keras module also, that I evaluated it. So I just evaluated it. I'll say reg dot evaluate. I am passing my test data. I am passing my test data and my y test data, which is present. Now, as you can see, it is getting evaluated. Now it is using 271 epochs, right? It is selected my epochs on my own. It did the all the calculation behind it, and it has selected the right epoch which is necessary. So now it is selected 271 epochs. Previously we selected only 100 epochs. Okay, so now in this section only the epochs, the loss function is reduced drastically. As you can see, the last loss function is reduced drastically. In the loss function is 57. My input loss function was around 1000. It has reduced to 57. In my previous deep learning model which I used, my loss function was around, the least loss function around 318. So now see how drastically it has changed and how good my AutoKeras has performed. So now I'll just simply evaluate this model on my X test data and my Y test data. Okay, then I'll just predict it. Okay, I'll predict my results and store it under y hat test. Then I'll see my model summary, okay, how my model is used and what are the different use. It as it says that the first layer which is used is the ReLU function is used in both the ReLU function is used in both the layer. It is taken two layer and all of these are the different parameters and I think total parameters, the trainable total parameters are these, non-trainable total parameters are these. So now I'll be seeing my predictions. So this is my prediction. Okay, these are my predictions. Then I'll just see, and these are my sorry, this is my predictions only. This is my predictions and this is my test data. So you can compare it. Okay, it is basically the similar to it only. So now as you can see how good my model is performed because of the following things, because of the AutoKeras library and how low my loss function is. Okay, you can also do the hyper tuning in AutoKeras also. You can see their documentation and you can see how you can do the same and perform very good models. This was basically a general introduction of how you can make a small project with the help of this. So all the notebooks and data is provided to you. You can import, you can execute this model line by line. It will perform the same. You can make some changes. Then you can even apply this knowledge to other data sets and make new projects out of it. Thank you.